This is 1.7c, College Algebra, page number 152. We're going to start talking about transformations of functions, which basically means if we're given a function or a graph of a function, how are we going to move it around? It's not necessarily going to be in its standard location. Sometimes it's going to be shifted up or down or left or right or all of the above. And sometimes it's going to be skinny, sometimes it's going to be fat. And it's just knowing what's going to happen depending on what we do to the equation. So this is the library of functions in the very back of your book. And what I mean by a transformation is sometimes our graph, let's look at this one right here. Oh, no, let's look at this one. So notice that its vertex is at the point 0, 0. Well, depending on the equation, what we do to this x squared may shift this thing down here. It may bring it up here. It may move it over here. It may keep it on the line here. Lots of different things. It could flip it upside down. So there's a lot of different things that that general equation could do depending on what we do with, in this case, the x squared. So as just an x squared, it's going to look like that. But as soon as we do something to this x squared, like maybe put a 3 in front of it, or make it x squared plus 4, or maybe a 3x squared plus 4, it's going to shift this and make, it's going to look the same. It's just going to be in a different place on the graph. So that's what we're going to look at in this particular lesson today. So bottom of page 152, it says, if we have a graph and we, let's say, take g of x and we take our x squared and we subtract 6 from it. Now, according to bottom of page 152 in that blue box there, it says the second part, the graph y equals f of x minus b is the graph y equals f of x shifted down. So what that's saying is this graph, when we subtract 6 from it, whatever that graph looks like, which actually it's going to look like this, once we take 6 away from it, it's going to shift this down 6 units to minus 6 here. If this were a plus, it would shift it up 6 units. So this distance here would be 6, and this distance here would be 6. But because of the minus sign right there, it's going to tell you whether it shifts up or down. So a plus sign shifts up, a minus sign shifts down. Okay, middle of page 153. Now what we're going to do is if we have, and the book there says if we take this, what that's going to do by subtracting d from it is it's going to move it, it's going to shift it to the right. If we were to add d to it, or a number, it's going to shift it to the left. So, for example, if we have something like d in example 4, h of x equals square root of x plus 2 minus 3. Okay, so what this says, according to the bottom of page 152, that minus 3 means that when we have a graph, it's going to move it down 3. But this here, at one point, was a square root of x. And what did we do with that square root of x? We added 2 inside that radical sign. Because it's inside the radical sign here, it is part of the x. It's part of the function. So see here, we've got an x plus d. That's what we've got here, is an x plus a number. So it was the square root of x. But now under the square root I added 2. Okay, so it's not shifting left or right, or I'm sorry, up or down, it's shifting left or right. And so normally what I do is like, okay, because this is a plus, it's going to take a negative 2 plus 2 to make that 0. Okay, so because I'm doing a negative 2, it's shifting to the left in the negative direction 2. Now if this were a plus, so if we got rid of this, or a negative, if we get rid of that, then we have to add 2 to make this 0, so that means it's going to shift to the right 2. So it's not only going to move down 3, it's also going to shift to the left 2. So just the problem square root of x. Well, if you look at the back of your book again, it gives you what a square root of x is going to look like. So it says that the square root of x is going to start here and go this way. Okay, so what this means now that I'm adding 2 is it's going to shift this over 2 units. So now it's going to start there and go up. But this minus 3 means it's going to shift down 3 and actually start down here. Okay, so it shifted over and it shifted down. So now it's going to look like that. Okay, so that's what happened to it. That's what changed. Is the number that was attached to the x makes it go up or down, and the number that's tagged on to the end decides whether it moves. Or I'm sorry, this makes it go left or right. This makes it go up or down. Okay, so if you look at part A of example 4, all that's happening to this x squared is we're subtracting 6 from it. So that means the graph is shifted down 6. If we look at B, we've got, what does it say? G of x equals the absolute value of x minus 4. So, the thing that's different is the absolute value of x gives me a graph that looks like this. Okay? When I subtract 4 from it, it means that I am shifting this graph, this red graph, to the right 4 places. 1, 2, 3, 4. And then it's going to be the exact same. Since nothing is added to it, like a plus 3 or subtracted from it, it doesn't shift up or down. It just moves left or right based on what this is. Since it's a minus, it moves it over to the right. So we already did the square root of x plus 2 minus 3, so we're good to go there. So let's move on to reflections, bottom of page 154. Okay, so when we're reflecting, we're either reflecting across the y-axis or the x-axis, at least at this point. You know, there will be a time later where we will reflect across y equals x, but right now let's just worry about the x-axis and the y-axis. If we're going to reflect something across the y-axis, that means that if we have a graph here, the reflection of that across will just be that. So it'll be flipped across the x-axis. So in order to find out what that looks like, all we have to do flipped across the x-axis is put a negative in front of the function. So our function is this here. If we put a negative sign in front of it, we just flipped it across the x-axis. So if they ask you, is this flipped across the x-axis, and they just give you these 2 bits right here, the answer is yes, because all we did was put a negative there. Okay, so across the y-axis is a little bit different. Let's look at the example on page 155. We have y equals 2x cubed minus x to the 4th plus 5. And we have y, well, let's just look at that one right now. So the question is, is that what would the flippage look like? Okay, what would the equation for flipping it across or reflecting it across the y-axis look like? Well, the formula says that all we have to do is take our f of x, which is our y right here, and turn it into f of negative x. So we're not just going to take this whole thing and put a negative sign in it as we did up here. We're going to take, and instead of replacing x here with whatever's here, in this point x, we're going to replace wherever x appears with a negative x. So it's going to look like this. 2 negative x cubed minus negative x to the 4th plus 5. So this is going to be negative 2x cubed plus x to the 4th plus 5. So there is the equation for it flipped across the y-axis, or reflected across the y-axis. So see the difference? Here we're replacing the x in the equation with a negative x. So every time we saw an x, we put a negative x in its place, and pretty much it just changed the signs here. Over here, what we did is we took the original and we put a bracket around it and put a negative sign in front of it and distributed that negative sign, and that gave us how it was reflected across the x-axis. So those are the two things to keep in mind. If you look on the top of page 156, it talks about what that reflection is going to look like, reflecting it across the x-axis and the y-axis. And we'll do an example in the next video, and hopefully that'll make a little bit more sense.